Honorable Pro Vice Chancellor Sir, CSV2 Bhilai, Professor Sanjay Agarwal Sir, to please welcome Shri Heman Ji with a bouquet. Now I request Director Sir, University Teaching Department, Dr. PK Ghosh Sir, to please welcome Professor Geetam Singh Tomar Sir with a bouquet. Now I request Registrar CSV2 Bhilai, Dr. Ankit Arora Sir, to please welcome Shri Anirban Das Gupta Sir with a bouquet. Now I request Dr. R.N. Patel Sir to please welcome Professor Saad Mekhle with a bouquet, sir. Sir, please. Now I request Dr. P.K. Ghosh Sir to please present a bouquet to Honorable Pro Vice Chancellor Sir, CSV2 Bhilai. Now I request Dr. R.N. Patel Sir to please present a bouquet to Registrar CSV2 Bhilai, Dr. Ankit Arora Sir. Again, I request Dr. R.N. Patel sir to please present a bouquet to Dr. P.K. Ghosh sir, Director CSV2 Bhilai. The University Teaching Department CSV2 is reaching new heights under the able leadership of Director Professor P.K. Ghosh sir. Organizing this international conference would not have been possible without his guidance and support. I kindly request Professor P.K. Ghosh sir, Director UTD CSV2 to please deliver a welcome address. Sir, please. Please give him a huge round of applause.
IEEE International Conference, Electrical, Computer and Communication Technologies, ICECCT 24 में पधारे समस्त लोगों का मैं तहे दिल से स्वागत करता हूं, अभिनंदन करता हूं. It is my proud privilege to welcome the chief guest of today's function, Professor Bansidhar Maji ji, Honorable Vice Chancellor Veer Surendra Sai University, Bodla, Odisha. He has come all the way from Odisha to bless this particular event. Sir, I am highly thankful to you for blessing us and making And it is a privilege to welcome you, sir, here. He had been here to bless us in a number of times and was instrumental in inaugurating and taking the advantage of the advanced labs that the university teaching department has developed. Sir, I welcome you. I take this opportunity to welcome the Honorable Vice Chancellor, sir. Actually, he is not here because of some other issues, but it is only his patronage and the constant motivation that this type of activity is being conducted here. So I welcome Honorable Vice Chancellor M.K. Verma, sir. I welcome Dr. Saad McLeaf, Distinguished Professor Electrical Renewable Energy, Swinburne University of Technology, Melbourne, Australia. He has come all the way from Australia to make this particular conference a successful one. A learned person, a great academician, researcher, and I'm sure that the students and the participants will be taking the benefit of his presence. Sir, I welcome you once again. I welcome Professor. Research scholars, students, and participants. I once again sir, I will like to bring just a few more minutes that this university teaching department was established with so this is something I thought to share with you. In this occasion, I thank you once again for coming over here and spending time and blessing us. Thank you.
Thank you so much, sir. This three-day conference is a collaborative effort of CSPTU team and the team from IEEE section. The idea of organizing an IEEE International Conference on Computer and Communication Technology was the brainchild of Dr. R. Patel, sir. This international conference has been powered by Chhattisgarh State Power Transmission Company Limited, Chhattisgarh State Power Distribution Company Limited, MathWorks, Sarda Energy and Minerals Limited, Chhattisgarh State Power Generation Company, Steel Authority of India Limited, ARK, and Consort. May I now request Dr. Anand Patel, sir, organizing chair, to kindly brief us about the conference. Sir, please.
Thank you very much. As the organizing chair, I would like to give you a brief overview of this 3 days program to all of you, respected chief guest Maji sir, this guest of honor Hemant Verma sir, Toar sir, Das Gupta sir, uh, our Vice Chancellor Sanjay Agarwal sir, Director PK Ghosh sir, all the distinguished dignitaries from different institutions and students, participants. So this 3 days program actually has beginning today. It has many things. It's like it actually began 2 days before the pre-conference workshops, sir. We had three pre-conference workshops, and all of them are different fields. One was in MATLAB, one was in OpenRT, and another one was in AR/VR. So we also have another pre-conference today. So these are the four pre-conference workshops. We also have a project competition. So it's already ongoing, sir. Beside this room, we have. I'm proud to tell you that we have 150 institutions under CSVTU, and we have participation in project from different streams, from pharmacy, from engineering, from diploma. So there's a project competition going for this workshop with the students. Followed by this, we also have poster presentations on different themes by the students and scholars. And of course, the main part of the conference is the technical paper presentation. I am proud to give you some data. So, as you know, the theme is International Conference on Electrical, Computer and Communication Technologies. So, we cover basically core three branches: electrical, electronics and computer science. And this is the 6th edition of this conference. This conference is known worldwide, and we are proud to host this conference this time at CSVT. So, in this conference, sir, we received around 1724 papers, out of which we accepted 263 papers, and then we got registered 225 papers. So total acceptance ratio is only 15%. So you can understand this conference is a very prestigious conference. It is having submission from 12 countries. So it's a thorough review process through which it has gone through, and we got some of the best papers, which will be presented in next 2-3 days. And each of the paper sessions, we also have some best paper awards. For the posters also, we have best poster awards. And we also have for the students the cultural programs in the evening today by the university students, and tomorrow are the national artists. So I request all of you to kindly participate in all these programs and bless us. We are very much blessed, sir, that all the distinguished guests are here. This is the first time this university is holding IEEE conference, and you are our distinguished host. We are very thankful to you all, and we hope that this will continue as a tradition. Each year, this will become a tech fest. So this 5-day program is like a tech fest for the university. It's the first tech fest, and we are very honored to have all of you. We are also very honored to have the different speakers from different states of the country, all the students, and we are actually looking forward to your blessings and your kind guidance, support. Thank you so much. Thanks a lot. Thanks to everyone. Thank you.
So we are delighted to have with us today Professor Geetam Singh Tomar sir, Chairman of IEEE MB section. Professor Geetam Singh Tomar sir received his UG, PG and PhD degree in Electronics Engineering from Institute of Engineers, Kolkata, REC, Allahabad and State Technological University, Bhopal.
Everything is available online nowadays.
So please give a huge round of applause.
So good morning, and it's a nice place and nice event to be part of it. First of all, let me congratulate this university for hosting first IEEE Entrance Conference. But to begin with, I should admire the pains taken by various guests. First of all, I appreciate Professor Maji, the Honorable Vice Chancellor, and academician. Forget about Vice Chancellorship, but he is a true academician. Wherever you call, he will be available. It means he is having some intent to be with you. Now it is up to you how much you take from it. That is what I admire his always, because last week we were there in OP Jindal. So without saying much, now it is up to you how much you take. Honorable Gupta, he is your own family member, and I know what is commitment and what things he has. Now it is up to us how much we should take from him. We are in business, but we need to take many things from him. So we need to know what are the ways and means to take maximum help and benefits, because he has everything, starting from place to other financial help. So I admire his presence, Shri Verma sir, again technocrat, then Professor Sanjay Agarwal, Professor Ghosh, who has been working for this event for I think last 1 year. And finally it has come to Professor Saad from Simba University, then all other guests, delegates, and the reviewers who are not visible physically. Because any conference, when you have such a high number of submissions, then we should have reviewers first and then all others. Because being authors, you can put anything, including garbage, in the conference, and they have to take out the good things from that garbage and good research. So why at all we are here? That is the first thing in our mind we should get, because wherever we meet, there is some cost. Whether you are connected directly or you are connected indirectly, it's always, when you go somewhere, try to utilize that time, because this is the only one thing which does not return if it is gone back. Everything is in return you'll get, but this time is never it is coming back. So wherever you are, you give your 100%. Even if you are passive listeners here, still leave that mobile for half an hour or 1 hour and listen something. Even if it is negative, still it will help you, because you will not use that negative mindset for wasting your time. And that is what research is. Whatever comes to your mind, how research comes. Because these events we are organizing, especially conferences, it is for instant research presentation. It means whatever things are faced by society, some problems are there, you are finding out the solutions. Those solutions are put on paper. Those papers are being scrutinized. If it is good, comes to the event. It may be positive or negative. If it is positive, you will further refer to your next research. That is what called citation. And while we are talking about citation, don't forget, one person is sitting here who is having more than 50,000 citations. Now you can think of, if he has more than 50,000 citations, how much time he has devoted to the research. Now it is up to you whether to take benefit of that gentleman or just take one photo and go away with that photograph. That is one remembrance. But the main thing is, what insight of that technology which he has worked on is with you. For that reason only we have conferences. Otherwise journals are there, you publish your work in journals. No one is seeing face to face. Even on online mode, it is not. Your paper is going, publishing, it may be 1 year, 2 years. If it's a good journal, it will take 2 years by the time the technology is getting old. So it is always better to have your publication in conference first. Then you work on that particular area and improve it and put it in journals. At least positive or negative, because if your paper is rejected, some negative concepts or aspects have come up, it is not bad, but we have to go for 15%. It means we have to sort out from that list. Your paper may be good, but that thing might have not come to reviewer's mindset at that time when he was reading. So don't think it is bad, but still some comments have come. Work on those comments, then put it again to some other place. And even if it is negative, other persons will not waste their time in that same direction. So it has to be available somewhere in the form of online mode or poster mode, or otherwise in some other conference again. Don't be scared that once it is rejected at one place, second place I should not put. You should go again with the whatever comments you have got, improve on that, again put it to some other conference or journal, again you will get maybe once, twice, thrice it is rejected, no problem. But the mindset you have taken for particular work, do not leave it until unless it is proved to be garbage. So that is what concept we should have. Another concept is that research is for PG and PhD. That concept is killing our academics on daily basis. Because when we are in UG classes, we are always pushing on the contents. That is one part. Suppose any university you take, any syllabus you take, you cannot cope up with the current trends of technology. Whatever university you take from number 1 to number 0 in the world, you cannot have instant changes in syllabi. So don't take that one concept that our university has very old syllabi, that's why we could not do anything. That is just escape path, nothing else. Any day you take, if this technology is developing day by day, you cannot change the papers day by day. Whatever time you get this degree, it is always the piece of paper of obsolete technology. Whatever day you get this degree, it is just one certificate that yes, you have gone through for 4 years. The basic constants have been taught to you. And another thing, what is our responsibility? To teach how to learn new things. If you are able to give this direction that we have to teach how to learn new things, then everything is done. That will be done only if we give them the environment of research. Because new thing comes always when you refer the old. And that is what research is. Innovations do not happen daily basis. It is not planned. Innovations are generally unplanned. You cannot plan all innovations. It's only 2 to 5% innovations are planned innovations. Otherwise, it is outcome of some mishap or some other mix-up of technologies. So anyway, we have to work on for this knowledge only, that yes, how to learn the new things, how to put up in research manner, so that if you are able to give involvement at UG level, that research is part of UG, then this university will be blossoming. If you teaching that yes, only PG and PhD is only the place where research to be done, then research will be zero in that particular institute or university. That is 100% certification. So we need to give involvement at UG level, and automatically you will have good involvement, because when research involvement comes, it becomes academic involvement. So thank you very much, and we should appreciate this effort and wish that all these three things will come up with the good knowledge for futures to come. Thank you.
Thank you so much, sir. Thank you for your inspirational words. I would proudly like to tell you, sir, that our 6th semester students who went for internship have published 3 research papers in 6 months. They are part of publication. Thank you so much for motivating, sir. Please join me in extending a warm welcome to our esteemed guest of honor this morning, Shri Anirban Gupta, sir. Shri Anirban Gupta is a distinguished alumnus of IIT BHU in metallurgy. He started his career in Center for Engineering and Technology (CET) of SAIL in 1986. During being in CET, Mr. Gupta worked in several important areas which included preparation of feasibility reports and tender specifications of various projects in SAIL. Collaborating with McKinsey and Company for restructuring of SAIL, formulation of SAIL's corporate plan in 2005 and 2012. He has been a key member in amalgamation of ISCO steel plant into SAIL. He has been in the post of Chief Executive Officer of ISCO Steel Plant and CEO of Durgapur Steel Plant and Alloy Steel Plant of SAIL. Sir is not only a leader in this field but also a visionary whose contribution has significantly impacted the steel sector. May I please invite Shri Anirban Gupta sir to address the gathering. Sir, please.
Namaskar. Good morning. A very good morning to you all. Dignitaries on the dais, Professor Maji from BSSUT Odisha, Professor M.K. Verma in absentia, Hemant Verma ji, Chairperson CRC, Dr. Toar, Chairman IEEE MP Section, Dr. Saad from Shri University of Technology, Australia, Professor Ghosh, and my dear faculty of CSBTU, distinguished professor, alumni, academia, and my dear students, and dignitaries and the delegates. It's indeed a great pleasure and privilege to be addressing you in this 6th edition of Electrical Computer and Communication Technologies Conference. I'm extremely happy to note that CSBTU is hosting the 6th prestigious conference, and when the numbers were read out to us, they were really astonishing. More than 1700 plus papers, out of which 200 odd have been chosen, about 15%. So I can really kind of gauge the quality of the papers which would be deliberated in the next 2 to 3 days under this conference, and I'm very sure that a lot of extremely high class papers will involve, which will enrich the knowledge of this university, this country, and the entire world. Friends, I am from the industry, so I know the importance of research. So there, the universities have two purposes. I mean, one being making the students good enough to be employed. That's one purpose, where you read out the employment statistics. But which is much more important probably is to do good research, which is really applicable or which is really good for nation building and for the sustainability of this world as we know. I mean, friends, you know the challenges before the entire world today, which is sustainability. We are generating carbon dioxide at a pace which is just not sustainable. You can see the ill effects of increasing the carbon intensity throughout this world in terms of very high temperatures, record temperatures, unpredictable weather patterns, wildfires, flash floods, you name it, we are having it. And we also used to have them earlier, but the frequency of the same has increased tremendously. And it is our collective duty to see that we reduce these ill effects, move towards decarbonization, go towards carbon neutrality, because we need industrial development on one hand, and on the other, we need to do it in a way which is sustainable. Without sustenance, this earth will not survive. So I appeal to all of you who are excellent, bright, young minds to to kind of focus your research in this area, which will really do good to the society. And electrical, computer, and communication engineering will, the good papers will really contribute in making the world a better one. I also invite you to take up many projects in the industry, and you have our steel plant very nearby, next door, where you can take a lot of projects. We are having a lot of collaboration with CSBTU. They are also doing a lot of teaching in our employees, including contractual employees. So I think we should, going forward, make this bond stronger and take advantage of each other's expertise and facilities to make India a better country and the world a better place to live. So, with these words, I wish you all the very best for this 3 day conference, which is starting today. And I'm really, really hopeful that lot of implementable ideas would emerge from this discourse and these deliberations and the discussions, which we can implement in the industry, in the society, so as to make this lovely, lovely earth a better place to live. Thank you very much. All the very best.
Thank you so much, sir. We are also delighted to have with us Shri Hemant Verma, sir, Chairman, Chhattisgarh State Electricity Regulatory Commission. Sir, we are honored to have you here. Shri Hemant Verma, sir, did his BTech in Mechanical Engineering from NIT Raipur, MTech in Energy Studies from IIT Delhi. His he's having work experience of more than 19 years in power sector, and sir has been part of various organizations. So without any delay, I would like to invite Mr. Hemant Verma, sir, to address the audience. Sir, please.
Good morning, friends. It is a great honor and privilege to address you today in the inaugural session of IEEE International Conference at Swami Vivekananda Technical University, Bhilai, in the presence of Professor Bansidhar Maji, Dr. Geetam Singh, Anirban Gupta ji, Director in charge BSP, my friend Dr. P.K. Ghosh, R.N. Patel ji, and Pro Vice Chancellor Mr. Agarwal. This prestigious gathering brings together some of the brightest minds in the field of electrical engineering, computer science, and communication technologies. Our collective expertise and shared passion for innovation are the driving forces behind the remarkable advancement we celebrate today. First, I would like to extend my heartfelt gratitude to the organizing committee, the distinguished members of IEEE, our gracious host at CSPTU Bhilai. It is credible that IEEE student chapter of UTT is very active and organizing the international conference just after 1.5 years of its formation. So, big compliment to the office bearers and mentor Dr. R.N. Patel ji. This kind of activity is going to give exposure to the faculty, members, scholars, and students of new dimensions. Lot of, as I have heard, lot of research papers are going on to be presented from within and outside of country. Expert talk, project competition, poster presentation are being scheduled, which will be beneficial to all, and it is up to the participants how much they can grab. Your dedication, meticulous planning have made this conference possible, creating a platform for the exchange of ideas that will shape the future of our industries. For the guest who has come from the outside of our state, I want to inform that our state, Chhattisgarh, is very rich and abundant natural resources are available with us. It is one of India's leading states in terms of mineral production, coal, iron, and bauxites. This state has a diverse topography, featuring forest, hills, and plateaus, rivers, and many other places our guests will be visiting after the conference. Very rapidly, Chhattisgarh is growing as a educational hub. Premium institutes like IIT, IIMs, and AIMS, Technical University, Swami Technical University, Hidayatullah National Law University are here. And these all institutes give good opportunities to the students and researchers to choose the field of their interest. Similarly, that Chhattisgarh is, since I am a power sector man, so I can say that Chhattisgarh is a power hub of our India. We have a surplus generation and we supply to the other states of the India. Power sector is a vital part of economy managed by the Chhattisgarh state power companies, mainly state governments and NTPC power plants are there. Efforts are going on to enhance infrastructure in the power sector to reduce transmission losses and supply you 24 by 7 supply. The title of this conference, yes, conference, particularly relevant because in the power sector we use this communication technology very well. We are going to uh, install the smart meters where the communication technology will be the major role to play. Where in the smart meters we will be handling the disconnection and meter reading remotely. So I wish lot of success to the conference. My gratitude to organizers again. Thank you very much.
Thank you, sir. Knowledge is of no value unless you put it into practice. Chhattisgarh Swami Vivekanand Technical University is famous for its innovation, dynamism, and persistence. For seeking and adopting innovative methods to improve the quality of higher education and hence bearing the torch in the field of academics and research. Under the able leadership of Honorable Vice Chancellor Sir, Professor M.K. Verma Sir, and our Honorable Pro Vice Chancellor Sir, Professor Sanjay Agarwal Sir, CSV2 has transformed itself into an institution of par excellence which conducts quality research and teaching. They have been the beacon of excellence for Chhattisgarh Swami Vivekanand Technical University. Their visionary leadership and dedication have significantly shaped the future of countless students and the institution as a whole. May I now please invite Honorable Pro Vice Chancellor Sir CSV2 Bhilai, Professor Sanjay Agarwal Sir to address the gathering. Sir, please. Please welcome him with a huge round of applause.
Thank you very much. Good morning and warm welcome esteemed guests, my dear faculty members and students. It is our privilege to welcome you all personally and on behalf of our Honorable Vice Chancellor, Chhattisgarh Swami Vivekanand Technical University, Professor M.K. Verma Sir, in today's International Conference on Electrical, Computer and Communication Technologies 2024. I am honored to welcome our Chief Guest, Professor Bansidhar Maji Sir, Vice Chancellor of Veer Surendra Sai University of Technology, formerly known as University College of Engineering, Burla, Sambalpur. Professor Bansidhar Maji has 3 years of industrial experience and more than 30 years of teaching and research experience in the field of computer science and engineering. Sir has served NIT Rourkela since 1991 and also served as a Director, Indian Institute of Information Technology, Design and Manufacturing, Kanchipuram, in various administrative positions as HOD, Dean, Chairman, Automation Cell, and as a member of various accreditation committee like NBA and NET. Sir has done a great amount of academic reforms, We are truly honored to have such a diverse personality as our chief guest today. Thank you very much, sir, for accepting our invitation. We are also delighted to have with us Dr. Geetam Singh Tomar sir, Chairman of IEEE MP section, Mr. Anirban Gupta, Director in charge of Bhilai Steel Plant, who is like our family member of Chhattisgarh Swami Vivekananda Technical University. I am also very much thankful to Shri Verma ji, Chairperson of Chhattisgarh State Electricity Regulatory Commission, Chhattisgarh, who accepted our invitation. CSBTU is very thankful to our special guest and keynote speaker, Dr. Saad from Swinburne University of Technology, Australia, who agreed to come over here to give his talk. Your valuable guidance will work as a positive catalyst in progress of our university. Thank you very much, sir. Additionally, we have pleasure of hosting Professor P.K. Ghosh, Director of University Teaching Department, and my friend Professor R.N. Patel, who is the Chair of International Conference of Electrical, Computer and Communication Technologies. It is our pleasure to have these esteemed individuals join us today to share their insight and expertise with us. I personally wish welcome you all to Chhattisgarh Swami Vivekananda Technical University, where we are dedicated to delivering systematic, efficient and high quality education in engineering, technology and pharmacy since our inception in 2005 under the Chhattisgarh state government. Our university teaching department takes pride in offering specialized MTech program in the fields such as energy and environment, biomedical engineering, microelectronics, structural engineering, environmental and water resources engineering, and urban planning. These programs are tailored to address contemporary research challenge and prepare our students for impactful contribution in their respective domains. Chhattisgarh Swami Vivekananda Technical University Bhilai is a premier institution that offers a range of unique and innovative features that set it apart from other institutes of higher learning. CSBTU offers a range of unique features that is set apart from other institutions. Some of these are include like unmanned aerial vehicle program, where hands-on training in designing, developing and operating unmanned aerial vehicles are provided. We have also remote pilot training organization, where training in aeronautical engineering, computer science and aerospace engineering for the career and aviation are given. Sir, we have also a e-library that has a state-of-the-art digital resources, including e-books, journals, and research paper. Sir, the beauty of this e-library is students take facility of this library even after passing their this particular BTech or MTech program. We have also Center for Entrepreneurship in Smart Agriculture, and this promotes innovative agricultural practices and technologies through training and membership. We have also Swami Vivekananda Yuva Kausal Setu, and this is an initiative to promote skill development and entrepreneurship among the young people. Sir, we would also like to highlight that we are adopting 48 villages and we are promoting rural development and community engagement through partnership with local organizations and the government agencies. We have also one facility that I have discussed Professor Maji sir yesterday, that we have a Shiksha Mitra. The motive of this Shiksha Mitra is to provide educational support to unprivileged students through scholarship, mentoring and career guidance. Sir, we have also a trained faculty member who have a capability to work on the supercomputer. We have also inclusive technology business incubator, that is ITBI. ITBI provides resource, mentorship and funding for the startup and entrepreneurs working in the innovative technology based project. As in the morning we have visited, sir, we have also facility of audio visual studio. This facilitated for the video production, animation and graphic design with advanced equipment and software. Sir, just I would like to inform you that we have developed 15 SWAYAM courses and now we are going to develop 18 more courses, and all these courses the funding is given by the Ministry of Education, and I am proud to inform you that under this course more than 30,000 students are enrolled, and these courses are open, available on the open platform. No fees are taken for this to joining for this courses. And under this course, we have developed 600 video, and now again we are going to develop 720 video. And I am very proud to inform you that this time we are going to offer 9 courses in Hindi language and 9 courses in the English language. CSBTU founder for Rural Technology and Entrepreneurship, Forte, which is a Section 8 company, has recently incubated 13 startups under the Nidhi ITBI scheme and provided with them an ignition grant of 34 lakh rupees. The organization has also received a CSR project with 4.59 crore from REC Limited, Gurgaon, to promote millet processing and food chains in Chhattisgarh. Additionally, CSBT Forte has received approval to establish a center of entrepreneurship in Smart Agri with approximate funding of 12 crore rupees. Further, CSBT Forte has received a CSR grant of 30 lakhs from the In Smart System Private Limited to promote self-employment in natural and organic farming. Sir, we are pleased to announce that this sixth international conference on electrical, computer and communication technologies at CSBTU in Durg, Chhattisgarh from 26 June to 28 June 2024. This globally recognized premier event attracted over more than 1500 research papers and proposals worldwide. This conference will provide a dynamic platform for the international scholar to showcase their latest research, result and discuss cutting-edge technologies in electrical, electronics and computer engineering and technology. The conference will feature invited talks, pre-conferences tutorials and workshop and referred paper presentation. To all participants of this conference, I extend my heartfelt best wishes. May this conference be a source of new insight, fruitful exchange, and valuable networking opportunities. Let us together explore and advance the frontiers of the knowledge and innovation in engineering and technology. Thank you and wish you all the great learning experience during this conference. Jai Chhattisgarh, Jai Bharat.
Thank you so much, sir. It gives me immense pleasure to introduce to you a distinguished personality, an academician par excellence, and a visionary leader, Professor Bansidhar Maji, sir, Honorable Vice Chancellor, B. Surendra Sai University of Technology, Burla. Prior to this, sir was a director of IIIT DM, Kanchipuram, Chennai. Sir has guided more than 21 PhD scholars, more than 150 research scholars of MTech, and more than 139 research publications in peer-reviewed journals. For his outstanding contribution in engineering and technology, Government of Odisha has conferred on him Samanta Chandrasekhar Award in 2016. We are indeed fortunate to have with us such dedicated and accomplished leader today. May I now invite Professor Maji sir to address the gathering. Sir, please.
Good afternoon to all of you, honorable dignitaries on the dais, Shri Anirban Gupta ji, Shri Verma ji, Professor Agarwal, the Pro-Vice Chancellor of the CSBTU, Professor Toar, who is the Chairman of the IEEE MP section, Professor Patel, Professor Ghosh, and our international guests, Dr. Saad, from Swinburne University of Technology, esteemed faculty colleagues of CSBTU Bhilai, and delegates from the different places, my dear students. In fact, without students, things are incomplete. At the very outset, I welcome our international guest, Professor Saad, to India and Chhattisgarh in particular. Sir, Sir has already pointed out that we are passing through the climate change where we should have heavy rains by now, but we are passing through different, and he should have made you feel that you have heard of India as a hot country, but the realization is in Chhattisgarh Bhilai. So, It is also a privilege to be a part of this particular conference. My sincere thanks to Professor Verma and Professor Verma in absentia, in fact, who has chased many a times that we'll be meeting. We have met earlier in different online platforms, but it was a dream to meet together because uh, it was great talking over the phones and meeting online. But unfortunately, he is away from the university. Thanks to Pro Vice Chancellor Sanjay ji for uh, like chasing and making me available here. It is a privilege, and I sincerely feel that events like conferences like IEEE 2024, which is happening here, workshops, colloquium, add a lot of values to the academic atmosphere. And I sincerely feel that the institutes of higher learning like CSVTU is rightly engaged in organizing such an event. Also, my sincere thanks because Professor Tomar was telling we met in OP Jindal University in last 2 weeks back, might be, in another IEEE conference. In fact, it is a effort by IEEE section of MP and Chhattisgarh for organizing such quality conferences. And these endeavors will definitely make universities or make the organizers to reach the next level. Dear participants, as we observe during the last several years, academic paradigm with respect to teaching, learning, and research in research institutions or universities of higher learning has taken a 180-degree paradigm shift, phase shift. It is shifted from the teacher oriented to the student oriented, exam oriented to the continuous assessments, ICT based, traditional to the ICT based, traditional to the inquiry based, theoretical to the project based learning, and also research and project based learning. The complete dependence on the textbooks, teachers has reduced to almost 50% because of the availability of the learning materials across the places in internet. However, teachers are never replaced. Teachers cannot be replaced, whether I say. Rather, their role has been shifted from one level to the other level, and this is in fact is a much challenging level to accommodate or to teach the students of this particular era, and they have to become a facilitator. And to become a facilitator, they have to be also in the real up-to-date stage, and that is only possible only they are chasing the technology which is changing very fast. Whether the present day conference themes, whether you talk about electrical, computer, and communication technologies, you see from the disruptive changes that has come in the electrical system, and which is actually the mother branch of computer and electronics or communications, whatever you talk about. And because of these disruptive changes in the electrical paradigm, in fact, this birth of this computer and communication, which has also changed from time and again. And the individual shifting, like we talk about in the electrical, we talk about e-vehicles to the battery technologies to whatever you talk about to the grid, smart grids or whatever you talk about. Initially grid, but subsequently again in the advent of the computers and the communication technology, we are in 5G talking about today. 6G is knocking at the door. So the changes are very, very frequent and very, very disruptive. So that with the advent of the technologies, we are moving very fast in terms of development, but at the same time, the combination of this individual shifting is one way, but when they are supplementing to each other, the communication technology is supplementing to the electrical to the computer technologies, the changes are very fast. Just like I was talking about a grid computing or grid system earlier, now people are talking about the smart grids because of the again smart when we are talking about the AI and advent of the technologies in AI, machine learning in the computers. So the changes are has to be conceived, must be realized by the teachers. Then only they will be able to deliver to the students. And a conference is usually a conceived as a gathering of the several individuals to discuss a specific issue, unlike different from the colloquia and convention at symposium. New concepts are being discussed in the conferences, fresh information is being shared with the experts, and academic conference is an event that brings together academicians, scientists, at which research findings are presented and they are being discussed among each other. And when we are coming to a conference, we not only share our knowledge, we create a community. We have an opportunity to network with each other. We learn from each other. There is a growth for the professional development. And when we meet in a conference along with the similar bent of mind who are working in the similar directions, it gives you the visibility, an exposure, what you are working with. And when you are working in your organization, you are working in your place, but when you come and discuss in a conference, in fact, you are visible to the outside world. And whether you talk about it is a criticism or it is a discussion or whatever, it gives you an opportunity whether you are in the right track or your track is diverted. So it is an opportunity. It should not be considered that I have been criticized or my work has been criticized. It is always an opportunity to see that whether I am in the right track or not. It also a great motivation that I am in a conference of this standard, and this kind of conferences are in fact the annual events. I remember in my like still my students and myself even, we used to chase our own conferences like IEEE International Conference on Image Processing. This is happening in Australia today. Next year it is happening in Cairo or whatever. I had an opportunity to present papers across in the similar conferences. It is a society conference, which are all sponsored conferences. So people must also try to do the society conferences because they are also the visibility. This is one level of visibility, but when you go to such kind of conferences, the visibility is more. I give one example. Those who are pursuing their research in image processing, they must not be away from the book called Anil K. Jain book. It was an opportunity when I was presenting my poster in Cairo. I was seeing that the next presenter is the Anil Kumar Jain, who is the author of the book, whose book we refer. That gives you a privilege that you are part of such a conference. Then, and in fact, in many conferences, these posters or the presentations are considered to be very, very like high level of contributions. And you get a lot of exposure to the similar people, those who are working in the directions, and you explain. Like typically when I say I'm exposed to several researchers, several people have understood my work, you get also the feedback from the people. So these are the venues or avenues where you have the like opportunity to expose yourself, to showcase your work, but also at the same time you get positive contributions from others' work to improve your own contributions. Dear participants, as all of you know that we are in the era of smart technologies. Everywhere where you talk about intelligent systems, smart systems, AI-based systems are all. And this particular things has come in. It is all because of the advent in the AI and machine learning, deep learning and other things. And this not only it is no longer becomes a part of the computer science topic, it has become a part of across the branches. As such, there are very thin layers or very thin boundaries among the boundaries of the different branches. Earlier, people were talking about electrical, civil, mechanical, metallurgy, computer science, whatever. But now people are talking about, I am a computer science, but how much interdisciplinary I am, how much I know beyond the boundaries. So this particular technologies, AI, machine learning and deep learning has further maybe removed the boundaries. So everybody is working on AI, machine learning and deep learning techniques. And as we know that the real world gets smart by connecting it to the computer, and the computer gets smarter by connecting to the real world. By collecting, there are 5 A's, all of you must be knowing. Awareness, like I'm connecting to the real world, analyzing the information collected, alternatives, selecting the best actions, we take the initiative. One simple example I will come back, and auditability is the feedback. And to do this real world to becoming smarter, both electrical, communication and computer technologies has played a vital role. The real advent of the sensors has made us possible to collect the information, whether it is from blast furnace or whether it is from the sea level 2000 feet below. We are able to explore the mining. So these different technologies has given birth to the Internet of Things, edge computing, cognitive computing, data science, and many more. But at the same time, when we are exposed to this connected world, we are also exposed to the threats. We are also exposed to the privacy. We are also exposed to the interoperability. So many areas has opened up. In fact, due to this technology advent and due to technology advancement, it has also opened up many other areas where we need to work on. Unless we do that, it will not be possible to work safely or securely. So, as rightly pointed out, the advent of the technologies benefits are substantial, but the risks and the obstacles are also associated with this. And these kind of conferences, when we are together, there must be several tracks, and in these tracks, we discuss these kind of challenges, the kind of possibility of threats or the possibilities of this. Like when we are talking about e-vehicles, the battery technology has improved, but at the same time, when we are talking about how to handle these batteries when they are out of order or when they are disposed of, that is another changing, or that is another challenges. So many challenges that given birth due to this different advent of technologies, and I'm sure that this conference will definitely bring the all academic outcomes, and I sincerely request all the participants, including students, just like already pointed out, don't be a passive listeners, actively participate, because when a speaker comes to your conference venue, when he presents, he receives inputs, it's also another learning from him. That is what the active collaborations or the active discussions takes place. So if you just listen and just say clapping at the end will not be sufficient. Either he has done everything wrong or he has done perfect. So that is, there is nothing called perfect in this particular world when we are doing any research. And so I request all of you to be actively engaged in this particular 2 days conference. And coming back, like Sir Professor Patel was telling, Professor Maji has traveled all the way from, but I am just nearby, and the next neighbor of Chhattisgarh, Odisha, and that to Sambalpur is very close by. And I have traveled across Chhattisgarh, all private institutions. Happy to see many of the colleagues here to whom I already know. And it is always a privilege coming to such kind of conferences. And maybe in the future days to come, we have collaborations, we have research collaborations, administrative collaborations, whatever you talk about, to take the whole educational systems ahead and the dream of national education policy to be fruitful. with this note, I thank again to the organizers and thanks to all of you. Thank you.
Thank you so much, sir, for your word of wisdoms. ICECCT 2024 received around more than 1700 abstracts, which were screened from their content and relevance of the theme. Out of them, 263 were selected for presentation as posters or oral presentations. The selected abstracts have been published as a conference proceedings. So, technically, the acceptance rate, believe my words, technically, the acceptance rate were as low as 15.25%. So, a huge round of applause for those who got it is selected for this. Now, may I request the dignitaries on the stage to please join for the release of the conference proceeding of IEEE International Conference on Electrical, Computer and Communication Technologies ICECCT 2024. Sir, please. Sir. May I now kindly request Honorable Pro Vice Chancellor, sir, to please present Professor Bansidhar Maji, sir, with a memento as a token of gratitude. Sir, please. I again request Honorable Pro Vice Chancellor, sir, Professor Sanjay Agarwal, sir, to please present Shri Verma, sir, with a memento as a token of respect. Now, I request Director, sir, UTD, CSV2 Bhilai, Dr. PK Ghosh, sir, to please present Professor Geetam Singh Tomar, sir, with a memento as a token of gratitude. May I now request Dr. R.N. Patel, sir, to please present Mr. Anirban Das Gupta, sir, with a memento as a token of gratitude. Again, I request Dr. R.N. Patel, sir, to please present Dr. Saad sir, with memento as a token of respect. May I now invite Mr. Akhilesh Tiwari, sir, Assistant Professor CSV2 Bhilai, to please deliver the vote of thanks.
Thank you very much, sir. So, first of all, a very good afternoon to all. It is indeed a great honor and privilege for me to get a chance to propose the vote of thanks to all the dignitaries who have witnessed this memorable and successful inaugural ceremony of this 6th IEEE International Conference on Electrical, Computer and Communication Technologies. I would first extend our gratitude to the leadership, our source of motivation, Professor M.K. Verma sir, Honorable Vice Chancellor, Professor Sanjay Agarwal sir, Pro Vice Chancellor, Registrar Dr. Ankit Arora sir, and Deputy Registrar Shri Bhaskar Chandrakar sir for their constant support and guidance. I would extend my thanks to IEEE MCE and Chair of IEEE MP section, Dr. G.S. Tomar sir, for showing true belief in us that we can collaborate for hosting this event. A big thank you for your time, support, and the faith you showed on us. Today, my words on this stage would not be enough to express the gratitude to our chief guest, Professor Bansidhar Manji sir, Honorable Vice Chancellor, VSSUT Odisha, for taking out time from his busy schedule and gracing the occasion. I would also like to extend my gratitude to our honorable guests, Shri Hemant Verma sir, Chairperson, Chhattisgarh State Electricity Regulatory Commission, and Shri Anirban Das Gupta, Director, Bhilai Steel Plant, for their time and effort to be a part of this event. I am so grateful to our foreign delegate, Dr. Saad McLeaf, Distinguished Professor in Swinburne University of Technology, Melbourne, Australia, for gracing the occasion. I also express my heartfelt gratitude to all the experts for pre-conference workshop, the panel discussions, judges for posters and project competition. To the leadership at University Teaching Department CSVTO Bhilai, I would like to express my deepest sense of gratitude to Director Sri PK Ghosh sir for his constant motivation and kind support. I would extend my sincere thanks to IEEE branch mentor and conference chair Dr. R.N. Patel sir for his constant efforts and dedication to successfully organize this mega IEEE conference event, and also the publication chair Dr. Thanga Prakash for his efforts. I am very much thankful to all the technical program committee members and in particular the technical reviewers who had put their time and effort to ensure the quality of proceedings. I would also like to extend my thanks to the admin staff of university, respected HODs, faculty members, research scholars, student volunteers, and teaching and non-teaching staff for their enormous cooperation in the organization of the event. I would also like to thank all the participants who accepted our invitation and have come here to attend the conference. Last but not the least, I would like to thank the IT support team for their continuous and all-time support. We have been fortunate enough to be backed by a team of sponsors: Bhilai Steel Plant, CSPDCL, CSPGCL, CSPTCL, and Comsol, MathWorks, Sharda Group, and ARK. We also thank the conference committee members for their extensive support. And I cannot thank everyone enough for the involvement they have shown and the willingness they have expressed to take on the completion of tasks beyond their comfort zone. May I conclude this vote of thanks with a huge round of applause, and once again thanks to everyone present today. Thank you very much.
Thank you so much, sir. I request the dignitaries to please take the seat at the front of dais, please. And I request all the audiences to please be seated as we are starting the keynote session and we'll be hearing Professor Saad.
So even if you use that, you have HDMI cable, right? So
have a
we
cable?
can connect that. No, we have. Connect.
I'm very happy to tell you that the first edition of the conference, I was the I gave a workshop and Professor Saad was the keynote speaker. So welcome again, Saad sir, from my side. Thank you so much.
Ladies and gentlemen, it's my distinct honor to introduce to you an illustrious figure in the field of electrical renewable energy, a scholar whose groundbreaking work has significantly propelled the advancement of engineering and technology. We are so delighted that we are joined by Professor Saad McLeaf today. Professor Saad holds the title of Distinguished Professor at the School of Science, Computing and Engineering Technologies at Swinburne University of Technology, Australia. He also serves as an honorary professor at the Department of Electrical Engineering, University of Malaya. Throughout his profiling career, Professor Saad has authored and co-authored more than 600 publications in prestigious academic journals and conference proceedings. His research has earned more than 50,000 citations, underscoring its significant impact on the field. Furthermore, he has successfully supervised more than 80 PhD students, contributing to the development of future leaders in engineering and research. Professor McKinley accolades include multiple Excellence Service Awards and the Best Teaching Award from the University of Malaya, as well as the highly cited researcher recognition from Clarivate in 2018, 19, and 2020. Ladies and gentlemen, it's my privilege to have with us Dr. McKinley. Without further delay, let's listen to him. Sir, please. Sir.
Yeah, I need this.
Okay, beta, please help him with the mic. Yeah, he's going to help. Mic, follow mic.
Oh, I need the pointer also. You have?
I'm afraid we don't have a pointer. Do we have a pointer with us?
Right now I can't find it, ma'am.
उनको बोलो इनका mic लगा दो पहले. They are helping you out.
No.
Follow mic लगा.
Follow me.
You can check the mic as well. Is the volume okay? Yeah.
Yeah.
Volume.
So I need the
Pointer चाहिए. नहीं है.
oh, I'm fine.
use this.
No, I'm not going to use this. I'm going to use this one. I need the pointer.
He's bringing, sir.
Great. So I think thank you very much. So I do like I'm not a politician. So I don't sit there. I sit in class like that's what how it is. I don't know how to stand there. I cannot probably go with that.
After an hour, it's a change of slide.
Yeah, maybe I need the pointer if possible.
They are bringing the pointers. So
Yeah.
till then, the
So
student is
thank you
going
very
to.
much for the
आप ऊपर
what I'm going to share with you this afternoon, it's actually my area of research, power electronics. I'm not sure how many of you know power electronics. You know, maybe I will explain to you a bit about it, and then later on, you know, power electronics. It's a part of electronics and power. So we use electronics to control power. That's why I call power electronics. So we use the electronics, which is the MOSFET diodes and all that IGBTs, to control power. Power, we're talking about voltage, current, high voltage, high current. So that's the role of power electronics. It's a conversion, energy conversion, but not from mechanical to electrical. It's electrical to electrical. Yeah, because energy conversions we can convert from mechanical to electrical, from different forms. But power electronics focuses only on electric to electric conversion. And electric to electric conversions sometimes becomes very important and very necessary. Yeah, good. So we use it on daily basis. And I will show you some examples on how this power electronics is becoming a very important component of our life. Okay, let me start with the very broad, or let me start with the outlines. Only 4 outlines. First one, energy and environment. Very complex equation. Energy, environment. They cannot work together, for a long time. So what we are trying to put them together now. Because energy, when you see energy, I have to burn oil and gas, coal to generate electricity. So we have a need for electricity. So what we have to do? We have to burn coal and gas. And through that burning, we're affecting the environment. And I think you can see the
the temperature, you know, and the humidity level and what we're experiencing now, you know. So we will talk about it, energy and environment, very complex equations, and we're trying to find the best solution for it. We, the scientists, have to find the solution, not the politicians, unfortunately, you know. But who make decisions most of the time are politicians, which they have no interest except to keep the position, to be re-elected and re-elected again and again. But we scientists are supposed to make the decisions which are the best for our environment and our future generations. And then next one, I will talk about the challenges in sustainable energy. Because for a long time, we talk about affordable energy, we talk about accessible to energy, but now we are moving to another level, which is sustainable energy, which is meeting our needs of energy without affecting the future generation need. Okay? So, and then I will be talking, what is the next one? Why it's not moving? Yeah. Yeah. Challenges in energy conservation. I don't know how many of you knows what is energy conservation, but it is a very, very important component. Before talking about renewables, before talking about, you know, whatever, you need to apply what we call energy conservation. Okay, I will explain what that means, energy conservation, later after this, you know. And then the last one, which is the grand challenge. So these are the only 4 outlines of my talk, you know, only 4. So, but it may take long than what you think. Okay, let's start with some facts. Okay, because we scientists always believe in facts. We, especially engineers, you know, we don't believe in, you know, we believe in facts. 0 is 0, 1 is 1. 1 plus 0 is equal to 1, not to 2. So that's how we learn, engineers, okay? So one thing, population of the world will grow by almost to 9 to 10 billion by 2050. I don't know. Some people see it as a curse, maybe like India. Some people are looking for it. They are doing all what they can to increase the population, but population is always on the negative. I give an example, Europe. Europe is going to, they call Europe now the old continent, because the birth rate is negative. They have no people to sustain the development. You know, meaning Australia also the same. Australia is on the negative. All the Western countries are experiencing very low birth rates. Okay, so India may be having a much better positions. Okay, so my take on these 9 billions, you know, is this, the next one. Energy consumption will be double. So world population will increase by 10 to 20%, but energy will be doubled by 2050. What does mean energy will be doubled? It means the energy consumption per person will be double. So the question is, from where this energy come from? Because as long as the demand, the consumers request, the companies will keep generating. From where? That's the big question that we have to answer. And if you don't believe, you know, the energy consumption is doubling, if I ask you a question, maybe I think most of you are very young, maybe let me ask some people who are maybe as old as I, you know. In the 90s, for example, how many of people have handphones? Maybe none. How about today? How many of you have handphones? Or maybe the other question, how many of you does not have a handphone? None. So I'm not, maybe people are getting maybe richer, maybe have a lot of money, but from the energy perspective, you use the device, you need the energy, right? For example, 30 years, 50 years back, how many of you does have an air conditioning? Or you ask your parents or your grandparents. None. Fan, maybe none, not even the fan. Even the light sometimes does not have. They don't have even cooking. They cook only on the traditional biomass. They don't have gas or electricity to cook, right? But now, we have, every one of us have a mobile phone. Everyone have a laptop, a desktop, an air conditioning, a fan, a washing machine, a fridge, just name it, a TV, all of it. What does it mean that? In order for these devices to function, what they need? Energy. So the energy consumption, and in the future, we will need more. We are more dependent on energy. So that's why energy consumption will be double. And I give you an example, I came from a very small village, very small village in the 70s, to give you some, the impact which I can see, from very small village. And in that village, it's not big, around maybe 100 or 150 houses. In the whole village, there is only one car. Only one car. And that car is very important to the villagers, because when someone's sick, it's the ambulance. When someone married, we bring the bride. When someone needs something important, that car, that person is very important, but a higher level, that person who owns the car, very important person, So I went, after 42 years, I went to the same place. I want to see my childhood place, What I found? I found the villages of car in every house. Every house, there is 3-4 cars parked inside, in front. Do you understand? From one car, the whole village, 2, 3 to 4 cars in every house. People fighting on the parking, where to park. So, economically, maybe they are becoming wealthier, better, maybe that's good. But what the car needs to move? It needs petrol. It's energy. So becoming more dependent on the energy. So that's actually the effects which we will see that's actually double. Okay, one more thing what's of the facts also. 65% of a global warming is due to energy generation and energy use. So the way on how we use the energy and the way how we generate energy is not efficient. That's why we have 65% is due to. So we have a lot of emissions. Okay, means it's not 100% efficient. That's why we have all these emissions, like the carbon dioxide, the carbon monoxide, all these kind of emissions. So our energy processes is not efficient in this. So I think this is, I took this slide. Most of the countries are talking about this net zero. How you transform, to net zero. You can see most of the countries, including the Europeans, still on the red. Even the advanced economies are still in the red. They have not even able to achieve a certain percentage of these energy transitions. Yeah, this is also, there are the labels of the countries is too small to see, but let me move to this. So what's the impact of these greenhouse emissions, What are the impacts? First one, extreme weather condition. I think if you ask your grandparents and your grandfathers maybe, how was the weather in Raipur, 50 years ago? I visit India quite frequent, and I was in Bangalore a few months ago. Bangalore experiencing a very hot weather, no rain. People are complaining, there's no water. This was not 50 years ago, even 20 years ago. So we see these extreme weather conditions. We see in Australia, for example, I give you an example, in 2019, I think you have heard about this bushfire. The whole Australia was burning. Never experienced. 2 years later, we experienced the largest flood in whole Australia. Never happened before, more than 100 years ago. I think only a few months ago, you have seen what happened in Dubai. Flooded, a desert. Never the amount of rain that experienced in one day is equivalent to the last 75 years. No one thinks that Dubai one day would be flooded, right? It's a desert. I don't know how many of you have seen it, but it's nothing. But it's flooded, the whole country is shut down. no flights, no one can move in, move out. So we see this kind of extreme weather conditions. In 2013, the whole Europe, from Spain, Portugal, France, Germany, Greece, all burning fires, were putting on fire. So we see this kind of weather conditions experience. We see what we call sea level rise. You know, if you see, I don't know, you have been some of, have you been to Maldives? I don't know, Maldives is a very famous place for tourists and, you know, for beaches, beautiful beaches, you know. But, you know, I've been there, you know, but I ask what is the highest level, ground level in Maldives? It's around 1 meter. The highest place in the country is around 1 meter above the sea level. And it's been decreasing year after year. They are monitoring it. So what does it mean? In a few years, Maldives will disappear as a country. Look into the Pacific Islands. You know, we have a lot of Pacific Islands between Indonesia and Australia. They have a lot of Pacific Islands, around 9 or 10 Pacific Islands. They are experiencing also a large amount of sea level increase, you know, means they're, sorry?
Any sea level what?
Yeah, many places will disappear actually. So this is, and all this due to the weather patterns. Okay, what else actually? So in the past 50 years, the world have lost 25% of topsoil, 30% of forests. I think you have seen this in India. There's a lot of cut off trees, you know, people, development, you know, never been replaced. So we see these kind of things. And very important, I think the last point here, which is if we continue the same as usual, we reach to what we call a state, we call it irreversible by 2050. What does it mean irreversible? It means whatever you do will not make any difference anymore. So if we want to do something, we have to do it today, not tomorrow. And yeah, sometimes there is a big debate, you know, who caused this global warming? We know who caused the global warming. It's the United States and the European during the industrial revolutions. And now who's causing the pollution is China and India. So the question is, can we continue the same? If we continue, everyone will be impacted. So I think, yeah, what the West did during the last century have caused this kind of global warming. But I think we should be responsible enough now to look for a solution rather than blaming who caused the problems. Because if like you are in a ship, so either you save it or we all die. It's the choice. To blame who bring the ship this stage or who destroy it, I think we should focusing more on repairing it and saving it rather than blaming each other. And I think India has a major role to play because economic growth is very rapid and the energy demand is very high. And India should be the leading in showing how we can sustain this growth with a sustainable energy supply, with the green, with the neutral carbon. And who is going to do this? We have to do it. You have to do it because you are the scientists. Don't wait for politicians to do it. Politicians will never think, the last thing they will think is about sustainability because it's very expensive, it's not popular, it's not going to bring a lot of votes for them. But scientists, we don't care. We provide the solution, the right solution for this. So that's what, so we need to do it before this irreversible states, okay? All right, so let me we are not affecting only the ground actually, we are affecting also the oceans. The acid level in our oceans is increasing and increasing. So we are affecting the marine life, okay? So the acid levels, you can see the color change here. It shows the acid level in oceans by 2050. If we continue, it will affect our marine life also. And we see this every day. Okay, so we open the TV, we see the floods happening almost everywhere in different locations, you know, in Africa, in Europe, in America, everywhere, almost everywhere. Not in few places. If we don't see the flood, we see drought. Means there is no balance, you know. It looks like there's the two extremes, shortage of water and the extreme. And you know, in Europe, I grew up in one place here called here in the border of Switzerland, in Grenoble. I don't know, you know Grenoble or not. Grenoble is famous of ski, where Michael Schumacher got injured in Grenoble. This is the Alps of between France and what you call Switzerland. And I was there in 2019. My father was sick, so I was there to visit him during summer. It was in July 2019. And the temperature reached almost 43. Never ever in the history of that place, because it's surrounded by mountains and all white, full of snow. So we never experienced this kind of weather before. But what happening there at that times, more than 20,000 people died. Because especially the very senior and what you call aged people, they cannot sustain this kind of heat because they never leave this kind of heat. Our houses there, no air conditioning. We don't know air conditioning. Yes, we know heaters because very important, very cold in winter, but there is no air conditioning that makes temperature lower. No, we don't know this. People start thinking how to install this air conditioning. It's never happened before. So it's increasing. You know, even the European part of the what you call the coolest places are experiencing very high temperature. So what is the challenges? First one is renewables. I think all of you know renewables. I think there is a big push of moving to renewables. Solar, wind, hydro, thermal, all these resources are very, very important. But I think before talking about renewables, we should talk about energy conservation. You know what that means, energy conservation? Energy conservation is use energy as you need. That is energy conservation. Means, for example, if I ask a question, do we need this light in the room now? Do we need it? We don't need it. Can you switch it off? The lights. What does make difference? Make the presentation clearer, right? We save energy. This is energy conservation. Because there is no one writing. I can see there is no one writing, you know. So we don't need a light. So why you have to put a light? So this is what I call energy conservation. So you use energy as you need it. For example, when we go air conditioning, you know, sometimes we go and put the air conditioning at 18, for example. Not here. Now it's more, I think, than 30, I think. It's very humid. But most of the time what we do, we have air conditioning at 18 and then we go and buy a jacket to keep us warm. You see the contradictory? So this is not energy conservation. So when you want to, for example, you want to go and buy something, you know, from the next door, you have to drive a car. Why you have to drive a car? You can walk. It's good for your health. You save the traffic. You save the energy. This was not 30 years ago, 40 years ago. We used to walk to the school. I used to walk 3 kilometers in the morning, coming for lunch 3 kilometers, go back 3 kilometers, come back in the evening 3 kilometers, go to the bed, sleep like a baby. But now, oh, you have to drop him in the door of the school, pick him up at the door of the school, keep him in, you know. So the children are spoiled. We were very healthy. We want to walk. Walking is the best medicine. So through this, we can save energy, a lot of energy. You know, just assume how many parents every day send the kids to the school in the morning, picking them up. I'm not talking about, yes, maybe parents are becoming more, I don't think so, the current parents, or we the parents, care more than our fathers. No, I don't think so. All parents are the same, you know. All our parents love their children, you know. Either now or yesterday or tomorrow or whatever, you know. It's parents, it's something built in us, you know, human. So I think that's the energy conservation. Energy conservation is very, very important. Because there is no point, for example, to put solar panel on the rooftop of this building and then waste it in the light. So why are you putting it? When you switch the light off, how much it costs you just now? Zero. Zero investment. Switching off the light. Zero investment. Putting the solar panel, thousands or hundreds of thousands of rupees you have to invest, right? But you can do it with just zero investment. So the first step in energy is to apply what you call energy conservation. Okay? So I always, and this have to be applied on your personal level, It's a way of life. It's not like something you need the government to apply it on you. No, you have to apply it on a personal life. And I always tell, I give you my personal experience, me and my wife, my wife is a lawyer, woman, lawyer. So what does it mean, From day one, I know I will never win any arguments. So I know, because we are engineers, we know 0 and 1, She lawyer, lawyer, prove the innocent guilty, the guilty prove innocent, Put the innocent in the jail and take the guilty out from the jail, eh? Yeah, because that's how they make money. So, we used to discuss, So she used to leave the light on the whole house, especially the living rooms, I see why you leave the light on. See, maybe because she doesn't like dark. I see we can maybe dim it, use dimmers, and then we beat some lights, dimmers. Maybe the kids, wake up in the middle of the night, go to the toilet, whatever. Say, there's dimmers. No. You have to leave it on. Better for security, better for... Let's say, if the thief comes, he doesn't need your light, he has his own tools, He will bring torchlight, he bring all the things he needs. The light, the last thing, he will think about the light. So, this is one example, and it took me years to convince her, The second example, always, so when we take tea, cup of tea, she always take the kettle, to boil the water. And then, the kettle is around 1.5, 1.8 liters of water, right? She put 1.5 liter of water to boil. And how much we need the cup tea? 200 ml, 200 ml. Maximum is half a liter. So she boiled 1 liter extra of water. And boiling the water is the largest energy consumption at home. If you don't know this. It's not the air conditioning. It's heating the water. You bring the temperature from 25 to 100. 75 degrees shift. To bring the temperature from 25 degrees, the room temperature water, to boiling temperature is 75 degrees. It consumes a lot of energy. So what did she say? She boiled 1.5, and then she make tea for 2, maybe half a liter. Then she leave the other liter to cool down. So I told her, can you just make half a liter? No, I have to make 1.5. Also, it took me 10 years, to convince her, because she thinks, and she cannot, maybe I have to change my mind. I never change my mind, because I believe in it. So that's how we should believe in this and apply it, at home. When you apply it at home, just imagine how many households will switch on 2 lights. How many bulbs around the world? There are billions of bulbs. So by just clicking that, how many tons of carbon emissions we saved? Don't talk about renewables, don't talk big. Just talk about how do you use your energy at home. Okay? So, and as I always say, I admire this president, I don't know, you know him or not, Jimmy Carter. Jimmy Carter is one of the best president the United States ever had. Not like the current one, sorry to say, like Donald Trump or this the old guy who doesn't know where to go, they go ask him to go this way, he go this way, So, unfortunately, Jimmy Carter is one of the finest, we call it statesman of the United States. And you know what he says? Energy conservation is an act of patriotism. Means if you love your country, use energy efficiently. And that's the type of politicians we should have. Politicians which really understands the impact of energy and energy consumption and energy conservation. So yes, patriotism, yes, you put the flag on your house, on your car. Yeah, that's a sign of showing patriotism. But actually, if you want to help your country, as you know, India is a net importer of oil and gas, right? So save the electricity. You are helping the nation. That's how you are. You want to be a good citizen? Use energy efficiently. And you need to be the example, the role model, the role example, you know, to use this kind of thing. So, for example, I'm not sure, you know, how you do it here, but I give you my personal example, how I do it. For example, I go to work. I never drive the car. I take the train. Yeah, because the train is convenient. I take me 1 hour to reach the university. During the train, I will reply all the emails. I will clear up all my inbox. So I reach the office, I do work. Come back, the same thing. Maybe send a few emails, reach home, play with the kids. Okay? So, using the public transport, I'm not sure in India how efficient or how it's good it is, but in Australia it's very good. But in Australia also they hit our pockets. You go, parking is $20 per day. Even the vice chancellor have to pay $20. At the university, parking. Vice chancellor have to pay. I don't know, a vice chancellor does not have to pay maybe. You know, I don't think so he pays, you know. So, but we pay, everyone, professor or whatever, students, everyone, you have a parking, you have to pay for it. You know, and that's pushing people to use the public. The vice chancellor comes with me in the train. We meet in the train together every day. So, using public transport, imagine how many cars we park. Okay? That's very, very important. Use, for example, when you go shopping, don't use the car. Try to move, so this is energy conservation. Okay, very, very important. I think I have spent more time. So in terms of resources or renewables, we have a lot of resources actually. You see, from the sun only, we have more than 2,850 times what we need of energy. So we use a very small percentage. Actually, we can cover what we need. And I think, I don't know, you have seen this. This is actually it's a solar airplane. It took off from Abu Dhabi and make around the world, you know, one cycle. It took off and land, you know. The good things about it is it lands, you know, because many airplanes took off, never lands, you know. So the good things about it, the technology has proven to be, maybe in the future, maybe part of energy that we use in our transportation sector come from solar. And I always show this example. You know, this QCell, QCell is a solar manufacturer, is a Korean solar manufacturer. They did a study. They see if we install this size of, I don't know, you know geography or not. This is Europe. So this is here Spain, Portugal, France, and so on. This is Morocco, Algeria, Tunisia, Libya, Egypt, and so on. So they say if we install this amount of solar panels, this type of solar panels, QCell, the efficiency, I think, around 15.5%, we can cover the whole world where they need of electricity. Let's assume this company is making publicity. Okay? Let's double this one, make it 4 times. Still good. So just small part of the world can supply the whole world of electricity. So this is very, very important. And there is a lot of research going on to improve this solar cells efficiency. You know, we still quite low. Actually, we are talking about around 20-25% efficiency. But there is a lot of research on improving the solar cells efficiency. Okay. And we are moving also into what we call hybrid. Because solar, the problem of solar is the land. You know, the cost of land is very expensive, especially in the big cities, expensive cities, you know. One of the ways is to look into what we call hybrid. Means you have a dam, on the top of the dam you have solar. So this, it generates electricity through the dam or water, and you generate energy also. And also can be in offshore platforms, onshore and offshore platforms. So this is actually thing. Okay, and we see the price. Okay, also we see the price of, I have to move a bit faster. The price of solar is dropping from $75 a watt to around 20 or 15 cents a watt today. So becoming cheaper and cheaper and more affordable. And what is the role of power electronics? We go back to the title, The title is power electronics, right? So what you can see here, this photovoltaics, PV, photovoltaics, we never work without this. What's this? These are power electronic converters. So solar will never work without power electronics. Because you need the converters, because you need to convert. Because most of the solar panels produce DC. But what we need at home is AC. So we need the conversion. And that's power electronics, which do the conversion. So power electronics is very dominant in this. We see a large scale now, I think including India, China, big countries already start installing large solar farms, which is very good. And again, in order for you to use this, you need to convert from these converters and this power electronics. I need someone to keep my time, because, we lecturers make money by talking. So when we start talking, we never stop. So someone, you are the MC, right? So how much time I have? I think I better stop then. I have not started the lecture, Really, To be honest, I have not. I think the wind, okay. I think wind energy is also very important. I think it's, the good things about it is going very high density now. We are reaching around 10 megawatts, single turbine. 10 megawatts, thousands of houses can be supplied with a single wind turbine. So power density is increasing significantly. Okay, I think we have to move this, so I have to move from there. Yeah, and you can see the power electronics also in wind turbines is increasing, from zero, I think here, maybe here, from 0% power electronics up to now we're talking about 100% power electronics. So power electronics also plays an important role in renewables. Yeah, I think I have to move from this. Yeah, okay, I have to maybe spend some time on this. I wanted to focus with me on this. If you understand this, then we can stop, So what does this mean? So this is a paper published in Science. We know it's Science. Science is one of the top journals, in our university, if you publish an article in Science, you get $50,000. I don't know in India how. I don't know, the Vice Chancellor here maybe. You should get the same incentives, because Nature and Science, if you publish one paper in Nature, the impact factor is around 46, 55, So these are top journals. And even in the ranking of the universities, you publish one in Science, you can put the university maybe 100 positions up. One paper. So that's why the university give you 50,000. 50,000 is nothing. Because 50,000 is the fee, in my university, is the fee of one student for 2 semesters. And by increasing the ranking, how many students they will attract? It's a, so, they give you peanuts. So university makes a lot of money of it, it's actually, so that's how it works. So I extracted this article from Science, and what it shows here. Okay, what it shows here, it's not my article, it's not my paper. Because one thing is in Nature and Science, electrical engineers is impossible to publish. Most of them is physics, chemistry, medicine, medical, so on, Engineering, pure engineering, mechanical, electrical, I don't think so we can. So what we can see here, okay, we have the carbon emissions. Okay, we have the carbon emissions, and then we have the years. So if we continue business as usual, what will happen? Like we said in the first slide, consumption will increase, right? So generation will increase. Demand. People want more energy. So what companies do? Generate more energy, right? When we generate more energy, what does this mean? More emissions. So it's a linear equation. Oh, sorry. Yeah, it's a linear equation. Increase the generation, carbon emissions increases. There is no way called no other options, because you need to burn. Yeah, you may. We will look into the solution how we solve it after this. But if we decide, for example, we continue generation, but we stabilize the emission. And this is what this article tried to address. So how we can increase the generation, but emission remain constant. And this is what we call this, the green line, the stabilization triangle. We call it the stabilization triangle. Because this triangle will stabilize the emission as a constant, however, generation will increase. So the question is, how to achieve this? Okay. Number one. This is the real statistics data. It's a research article. You can Google this article and read it. So number one, we need to install 1 million 2 megawatt wind turbine. Correct or not? Why? Yeah, because wind turbines will contribute to more generation but less emissions. So actually we are helping to, which is almost 300 times the current capacity. Okay, next. We need to install around 3,000 gigawatts of offshore, of solar power. Very clear, because solar will help increasing the generation and stabilize the I think we all know about this, its effect, Next, install, maybe this is a bit controversial, install around 700 gigawatt of nuclear power plants. In Australia, nowadays we have a very big debate, between the Labours and the Liberals about installing nuclear power plants. Liberals are supporting installing nuclears, Labours no. So there is a big debate, but I think from the emission perspective, nuclear is one of the clearest traditional source of energy. Yes, it has an impact. Environmental, maybe the cost the capital cost is very high, it takes longer time, and maybe have disasters. Nuclear is like I don't know, people talk about Fukushima, Chernobyl, right? But how many nuclear disasters happens? 2. How many people died from the cooled power plants? How many people are in the hospital because of the quality of the air? I always give this analogy, the nuclear power plant is if I ask you another question, let me tell you this. What is the safest mode of transport? Huh? You can Google it. What is the safest mode of transport? It's the airplane. But if one airplane crash in Africa, in India they will hear about it. In America they will hear about it, right? But it's the safest mode of transport. How many people die walking? It's more than the people dying in airplanes. The same thing is to the nuclear power plant. Since the innovation of this nuclear, only 2 disasters happens, which is the Chernobyl and Fukushima. But people are, it's a big. But how many people die walking? Just walking, no bicycle, no driving. We don't talk about the cars and motorbikes. No, walking, accidents. You will find like thousands of people die every day because of walking. So walking is not the safest way of moving, right? It's the transport, it's the airplane. But one airplane crash, everyone say, oh, big, oh, safe. Very worried when you go to the airplane, People think that you will never come back, But it's the safest mode of transport. The probability of an accident in an airplane is very 0.000, millions of airplanes took off every day. How many of them? Most of the time never do crash. The same thing for nuclear. So nuclear power plants, it's a very important component in the energy, what they call energy mix. You know what does mean energy mix? Means certain percentage of your energy should come from nuclear, certain percentage should come from renewables, certain should from coal, certain come from whatever. So if something happened, the impact on the country will not be huge. Because, for example, the price of oil or petrol increase. If you are dependent on oil and petrol, what happened? Everything else will be affected, you know. The cost of food, the cost of transportation, the food, everything, electricity will jump up. But if you have what you call equal percentage distribution, then your impact will be. So nuclear is very, very important component in this. Okay, what else? Increase fuel efficiency of 2 billion cars. The current fleet of our cars from 30 to 60 miles per gallon. You know, means the cars that we are using based on IC engine, the internal combustion engine, is not efficient. I don't know, you know, if you put 1 liter in your car, how many kilometers you can go? Depends. If you have a Ferrari, you have no move from, you are stationed, you know, 10, already 1 liter gone already. You turn on the starter, already 1 liter gone, you know? You know? But if you may be driving another car, yeah. Yeah. Hi. Hi, how are you? Yeah? Oh, nice meeting you, sir. Thank you very much. Yes, thank you. So now I got disrupted, you know. Vice Chancellor attended, so I am panicking, you know. You know already what to say, you know. Okay, thank you very much for attending our my lecture. You know, I am halfway. I hope I will finish it. So what we need to increase, like I said just now. For example, our cars, a normal car. You know, 1 kilometer in a good car, maybe can take you around 1 liter. Will take you for 10 kilometers. Depends on the car. I say, if you have a Ferrari, you start the engine, already 1 liter gone. What is the cheapest or the most economical? I think there is one small car in India, you know, which is Nano. Yes, Nano. Maybe 1 liter will take you 20 kilometers, right? So that actually, if you count the amount of energy in that 1 liter of petrol, amount of energy, and the distance, you can see there's a lot of emissions actually. It's not efficient. The IC engine is not efficient. So we need to increase the efficiency of these cars from 30 to 60. Means if this 1 liter take you 10 kilometers, we need to improve the engine to take you 20 kilometers. If that, we can reduce the carbon emission that is generated by transportation sector. Because transportation sector is the most polluted components in all the industrial other sectors, like industrial sectors, domestic, commercial sectors, agricultural sectors, and transportation sector. Transportation sector is still heavily dependent on fossil fuels. Okay, so we need to improve. That's why there is a big shift on EVs, electric vehicles, and this is one of the ways on how we reduce the emissions. Okay, next one. So this is one. Cut the carbon emission by 25 of the buildings. You know, means the construction, because construction also we use a lot of energy. Because she stand, you know. I think she told me, stop. You know, you need to tell me, as I said. We are lecturers. We make money by talking. So we can talk forever, you know. So we never stop. So you have to tell me, okay, you have 5 minutes, stop. 2 more minutes. This is the first slide, by the way, you know. So I have not started. Okay, never mind. We try to make it. Okay, so introduce what we call carbon capture. I think this carbon capture, you know, collecting the carbon and reutilizing it in building materials, storing it, is also one of the very options. So this, what we have to do, if we want to, what is the question? If we want to stabilize the emission. So my question is, Is it doable? Especially the youngest one, The question is, if we want to do this is the way, because energy demand, energy consumption will increase, as we said, linearly, right? Emission will continue to increase. The way to do it is this way. But the question is it doable? Why? Good. Yeah, that he says no. Anyone yes? Maybe more optimistic person? He's very pessimistic person, okay, maybe? Yeah, maybe a more optimistic. Yes, Ken. Okay, how? Why? How to do it?
The way I see it,
Are you an electrical engineer or not?
yes,
Okay, good. Yeah, because we have to, engineers and, like you see, lawyers think differently, you know? I have a very good example at home, Okay, yes.
but the way I see like there won't be any choice for next or maybe next generations if we don't align with these alternative measures.
Yeah, but I give you an example. If we do, like, let's take the most developed country in the world, United States. All right? That's the most developed country, right? The most powerful. But it changed the policy. When Trump being elected, what the first thing he did? He pulled out from the Paris Convention, right? That's the first thing he did, He see United States will not work towards cutting the emissions. And that's what I say. The politicians most of the time make the decisions, not the scientists. So when you have someone which is leading the most developed country, the most powerful country, says, I pull out from the Paris Convention. Paris Convention is, what is Paris Convention? Is limiting the Earth temperature by 1 to 1.5 degrees. And every country, including India, they say, we will do this. China, we will do this. And to maintain the Earth temperature below 1.5 degrees. So when someone comes and says, oh, no, or maybe, I don't know, in India, maybe a new president comes and says, oh, we don't comply. Or in China, for example, they say, we don't comply with this. So this is what will happen. So it's not sometimes the way you think these people think, Sometimes they don't care, They see we have lived our life. We don't care about the future generation. So from the perspective of an engineer, and we know the numbers, I don't think so it's doable, You know why? Because you see, okay, let's assume India. Let's take India as an example. Can India increase the installation of wind turbine by 300 times? It's impossible. Because when we see 300 times, means everyone around the globe will have to increase by 300 times, right? So some countries, economically, they are not capable. Technically, they are not capable. Financially, they are not capable. They cannot do it. So it's impossible to do it. So what is the solution? Are we going to surrender? No. We will not. So what's the job now is every one of us, in your area of expertise, you need to find a way how you can contribute. She's getting closer, She was sitting there, then moved there, then she's moving there, I don't know where the next step were, Maybe she will switch off the power supply, My microphone, Yeah. She's getting closer further, So I'm not sure, okay. So when you reach to the stage, I will stop. As long as you are there, I'm not going to stop, okay? All right, so, okay, I will give you one example only, okay? Since I have few examples, but I will give you one example from the power electronics, from my research. Because when you do research, sometimes we only focus on the very technical, very narrow-minded. We have to look into the big picture. How your research or output can impact the whole globe. You cannot sit very micro, I do this, I don't know. You have to see the impact. So what I'm going to give you an example how power electronics can save Very small modifications can save. I don't talk to this because now almost all our devices are power electronics. You go at home, air conditioning, inverter based. Washing machine, inverter based. Fridge, inverter based. Your lap charger, your TV, LED driver, which is power electronics. So everything at home now is power electronics driven. You know this, right? So everything is power electronics. So let me give you an example. I think I have to escape all of this. So this is just to give you some idea on the total energy we consume in 2012. 40% of electrical it's around 20,000 trillion watt of electricity. If you give you some analogy, one nuclear power plant generate around of 1 gigawatt, generate around 7 trillion watt hour of electricity per year. So you divide 20 by 7, you get around 3,000 nuclear power plants, around 3,000 nuclear power plants. So in 2012, we consume what is generated by equivalent to 3,000 nuclear power plants. It's huge. So 2012. Now we are 12 years later. So maybe this number already will be almost double. Okay. Just to give you this analogy, okay? So let me give you, I think I have to skip this, but I have to escape most of this. Yeah. Let me move to one example. Yeah, I'll give you this example. I think most of us knows this example. Do you know this? Do you know this one? This is a laptop charger, right? All of us have it, right? So, and this laptop charger, most of the time, what it gives you, it takes the AC, which is around 240 volts, or 200, depends on the countries, and then generate DC voltage. Okay? So it generates around, depends on the chargers, different models, between 8.7 to 19 volts. And then it goes inside the computer, different one. You have LCD, you have the CD, you have the graphic card, need the power supply, right? So it generates what you call, we have these VR, voltage regulators, and then you generate the voltage you need for each component inside the computer. Because not all the components on the computer operate at the same voltage. Okay? So we need this conversion. Okay. So this is typically how it works. Okay? Let me show you. This is how inside, if you open that black box, this one, if you open this one, okay? You open it, I don't know, if you have one burned already, it's good to open it, not throw it, open it and try to learn something from it. So if you open it, inside this is a circuit like this. This is what we call a flyback converter. Basic, very common topology. So what actually we did, this is what we call a topology. You see here, we have a voltage range, which is the voltage that we talked just now, between 100 to 400 volts, and then it generates this. Okay? Don't focus on this. This is an electric circuit, and most of you maybe doesn't know. So what we have here, we have one switch. Actually, what we do, we control this switch. We switch on and switch off to control the amount of power. Remember just now I told you power electronics is using the electronics, which is this switch, to control the power. So this switch, before this, we use what we call hard switching. Means switch at any time. High current, high voltage, just switch. Okay? So what we did actually, we modified this, we introduced what we call this soft switching. So you can see it's almost the same topology, see? Just adding small capacitors and small inductors. Okay? So we call it soft switching. Soft switching means switch at 0 voltage and 0 current. Means when you switch at 0 voltage, what does it mean? Power will be 0, because power is voltage times current. You switch at 0 current, power loss is 0. Okay? So let me show you the impact. So the efficiency, you know how it moves? It moves from 85%, yeah, maybe here better, 85%, almost 85, not 80, almost 85% to 95%. What does this mean? How many efficiency improvement? By just changing the switching from hard switching to soft switching. 10% efficiency improvement. You know what does means 10%? I know this computer consumes around 85 watts. That's all. Very low power. But how many laptops we have in Raipur? How many? Anyone? 1,000? 1,000. Let's see 1,000. How about India? How about you add China? How about you add Europe? How about the United States? So you look the global. That's why I say you need to see your impact of research globally. How your research can make global impacts. So we're talking about maybe billions of laptops and desktops, excluding the mobile phones. The same principle in the mobile phones, the charger also. We can apply the soft switching also, the same. So we're talking about billions and billions of laptops, and that can be have an efficiency improvement. You know how much? I give you how much? It's equivalent to what is generated by 60 nuclear power plants. This 10% saving, it's equivalent to what is generated by 60 nuclear power plants. Okay. I hope she forget me, you know. I think she cannot see. Okay. Okay, let me give you one. I think she's there. Let me give you an example here. This. I think I will focus on this one and I stop, okay? So, lights. Okay, like I said just now, you know, lights. Lights, you know, if we move from this bulb to this bulb, we save between around 4 to 5%. 5 more efficient. This is more efficient, 5 times this. If we move to this, the LED, we another 4 or 5 times. The question is, yeah, maybe this LED only 5 watts. Okay? But how many bulbs? Anyone have an idea how many bulbs we have in India, for example? Or in Raipur first? How many at home you have? In your office? In your shopping mall? You use the shopping mall. You use the shopping mall. In street light? In the governor office? So you're talking about millions and millions and estimated more than 100 billion bulbs around the globe. Estimated. Because we're talking about how many? We have 8 billion people. Okay, if we assume that each one only have for every person only 10 bulbs. Don't talk about homes. You know? Talk about different locations, you know. And you know, when I moved to Australia, you know, I purchased a house. You know, my wife focused on how nice, how, you know, lawyer. You know, again, you know, I focus. You know what? The first thing I did in the house. Can you imagine what's the first thing I did in the house? Can you guess? You know, I have a young 7-year-old son. So I told him, go and count for me how many bulbs at home. Outside, inside, you know. And I was surprised to see the number of bulbs. You know how many he found? 75. Oh, that's actually very worrying, you know. So how I'm going to control these 75, you know? You know, it's 75 bulbs. It's all LED, yeah, that's for sure. I will never install non-LED in my house. But 75 is too much to control. You know? So one house, we are 4 in the family, we have 75 bulbs. So, you know, you're talking about for everyone is 20. Almost 20, excluding the school, excluding the university, excluding that, you know. So I'm just telling you, just show you the figure. You know how much saving? If we switch to this, it is equivalent to 450 nuclear power plants. if you just do the switch from to LED. And LED, you know, it's power electronics. You need LED drivers. So there are a lot of other examples, okay, which I would like to share, but she's giving me not a good look at the moment already. So I will maybe, if you have a question or comment, please feel free. Thank you very much. Thank you.
First, let me apologize, Dr. Saad,
Yes.
for cutting down the time, but we have a schedule. Any questions, anybody?
Not questions, maybe comment. Huh? So because maybe some of you knows better.
Sir, there would be many questions, sir. Your talk was amazing. Every one of us loved it. We wish we could hear you more.
No.
So actually, really love the concept that you told about the floating solar.
Yes.
We can actually utilize that in many places which are right now not utilized. But at the same time, I just want to know the ecological effects on the biodiversity
of that particular floating solar. I'm not much idea about it.
Yeah. You're right. Yeah, good. Very good question, actually. And this is always the question. You have to know one thing. Everything that you introduce will have some side effects. There is no I call solution without its side effect. I know. I give you an example. You know, when the solar panels start the beginning in the 90s, you know, people talking about where we make the silicon from, where, from the sand, or what happened to the beaches, and that what's happened, the cost that we use, the energy that we use to fabricate the solar cells. But what we do in doing this analysis, we do what we call return of investment. Return of investment, you know, or we call the techno-economic analysis. We do it, that's the best word. Techno-economic analysis. We do technical and economical returns, including the ecological and environmental impacts. For example, one of the problems if installing dams, for example, dam collecting waters, is stopping fish from migrating. You know, some fish, the fish migrate opposite water, you know? So what's the solution? So the solution is we need to find a way how to provide a pathway for the fish to go back. And we did that. For example, installing wind turbines. What's the impact? Sound. Because you cannot imagine that you have in front of your house a machine which rotates every day. And as it gets older, the noise keeps increasing, you know. No one would like it. So what's the solution? Maybe use more, improve the design of their gearbox and to make it less sound, reduce the sound. And that's happening. You can see, you know. What else? One of the problems which we already, when we start the wind, birds. Birds fly directly to the wind. You know, the people who protecting the birds, you know, they make a lot of noise. What will happen to the birds? You know what we told them? Only stupid birds flies directly to the wind. You know? The smart one will go up and continue, you know. So what we did, we create some noise when the wind turbines turns, it's distract the birds from flying directly to the wind. So what I'm not very familiar of what's the impact of putting solar panels. Sure, they will have an impact because the sun will not go that deep. But I'm not talking about the seas. I'm talking about natural made, for example, dams, you know, ponds. Even in the sea, for example, when you put small parts of the panels on the sea, it will not affect the sea. It will have some impact. But the question is, what's that impact compared to the amount of coal and gas and oil that we burn on the environment? So it's like, you know, you are giving something, yes, there will be impact, but must be much lower, maybe 10 times or 20 times less. But there should be an impact, for sure, 100%.
So,
yes.
with that, I just wanted to just add on to that.
Yes.
We have been listening about the an exponential growth about the AI word, where
people are using lots and lots of energy. The OpenAI, the founder company for the ChatGPT, they're using 1,000 gallons of water and lots of energy in order to maintain and sustain that ChatGPT type of AI generated or large language models. And in the upcoming years, it is going to exponentially increase the energy consumptions.
Very
so
true.
how can, again, that ROI concept that you are saying, how can we implement that, and how this type of future can be taken care of? Like, because that cannot be, what I'm guessing, we cannot stop them from producing, because right now they are in US, tomorrow they'll be in India, tomorrow they will be in Australia and other parts of the world.
True. Very, very true. That's why I say this is actually part of what I said in the beginning. At the beginning, so we said the energy consumption per person will increase, and the AI is a part of it, because you use AI, I use AI, right? Every one of us use AI, right? When you go and chat GPT, you know, and ask him to write for you or improve a sentence, you are using AI indirectly or directly. Okay, so the question is, you know, as I say, everyone at his area of specialization need to find a way, like I say, for power electronics, by introducing just soft switching. That has an impact of 60 nuclear power plant saving. So in your area, for example, you are a material or civil engineer or whatever. So you look into areas where we can cut off the energy, because we still have not reached to the maximum saving, actually. Most of our energy processes are still inefficient. There's a lot of losses that we can cut off. Okay? Any other comments, suggestions, or disagreements?
Research topic can be how can we reduce the power that is the energy that is consumption by the large language model?
Yeah. But I think that question, that answer is here actually. I have it here. I have the question here. So let me show you this. I'm not sure I'm moving forward. You know, this is not part of my lecture.
Yes.
It's a part of the questions, right?
Sure.
Okay, so don't tell me this is I'm going back to my lectures, all right? So let's go back to this. Yeah, I think my answer is here. No, not this one. Yeah. Oh, not this one. Sorry. Yeah. Let me show you. This is my answer. You know this? You know this? I don't know. You know this or not? Maybe you're too young to know this. So you know, in the 70s, you know, we have the 4-bit microprocessor. You know, 4-bit microprocessor in the 1970s. You know, and then we moved 8086. You know, the computer, the first 8086, 286, 386, 486, Pentium 1, Pentium 2. I don't know now where. I don't know. I forgot. So I don't know. Believe me, I don't know which generation we are. i7 or i9 or whatever. I don't know what it is. So what does this mean? This is what? This is the integration level. So we're moving from hundreds of transistors to millions of transistors within single chip. So now we are talking about this, the 200 core. Here we're talking about around 60 million transistors inside a single processor. And that's what the AI use. They need the processing power. So that's how the AI operates. So if you look into this, from microelectronics people, thinks about how to increase the number of transistors so the processor become faster. But from power, this transistor needs power. How they can operate. So let me show you. So this is a 15 core. You know, this is a real 15 core processor. You know, 555 core. This is the PCB. You know, and let me show you you see, this is the processor, and this is the power supply. You can see almost 3-4 times the processor itself. This is having 60 million transistors inside. This one is a few transistors. So one of the way how to cut this, let me cut the power. So most of the time, these processors will operate like this. You know, you supply the voltage, you know, and then it operates. You call it like this. So what we propose this. We call it dynamic scaling. Dynamic scaling means supply the power, because most of the time these cores does not operate all the time. You have maybe 4 cores. For example, I have maybe my phone, for example, is a 4-core processor. But what do I use the phone for? WhatsApp, check the email. That's all. So how many processors are working? Hardly one. But the power is supplied to the 4 processors. If you have a computer, so the same. The people who play gaming, they utilize the processors to the maximum, You can see the heat. You can see the sound, You can see the sound of the processors. When you see the heat that generated. So that's the amount of power that is being absorbed. So what we did actually, we proposed what you call dynamic scaling. Dynamic scaling means supply the power only to the processor that's doing something. Not supplying the power to all the processors. And how much energy we save? Between 40 to 60%. Okay, again the question. How many processors we have around the globe? How many laptops? How many handphones? How many? It's billions of laptops. And that will save a lot of energy. And that's how the AI can save the energy through this. Thank you.
Thank you so much, sir, for this thought-provoking address. And I'll again say, sir, we would have loved to hear you more.
Thank you very much. Thank you.
May I now request Honorable Vice Chancellor, sir, for his blessings, please?
Thank you. Thank you, sir. Thank you. Oh, that's it, please. I'm not the Vice Chancellor. I'm just a lecturer,
So the path of Vice Chancellor is taking initiation from the lecturer.
Thank you.
So that is the initiation. And whenever we talk in very small particles, we come to the atoms, and below the atom, if we are going to have, then electron, proton, neutron, and everywhere we find that every particle is associated with the energy. And energy is the form of the universe. And also whenever we see this world, we can divide it into 2 parts. One segment is physical world. Physical world is related with all our sensors. This is human senses, 5 senses we do have, and whatever we can understand out of these 5 sensors of human body, whether it is eye, taste, or smell, hearing, this is going to define our physical world. And the knowledge of physics is based on all these sensors only. But whenever we try to go and think deeply about the source of universe, source of creation of the universe, creation of the creatures, how the life is continuing in all the creatures, we find that there are forces, there are energy which is beyond our all the 5 senses. Similarly, whenever we come to the physics, we go through space and time. Time is a dimensionless and no existence quantity which has come out of an observation of the movement. And whenever we find the basic characteristics of all the things which we can experience, whether we are scientist, engineer, or whatever we are, it is particle characteristics as well as wave characteristics, particularly electromagnetic waves. And prior to the previous century, we were taking it very separately. And it was a thought by the knowledge of physics that these two are separate entity. But whenever we go deep to the Indian philosophy, we find that they had defined it as one of the form of energy, and ultimate energy, whatever the name we are calling it, God, creature, that is there, which is beyond our 5 senses or knowledge of physics. Whenever the knowledge of physics is getting end from that, the spiritual thought, a spiritual power which is able to see the conversion of everything into the energy. And out of this philosophy of Gita, Bhagavad Gita, Einstein has come up with his physical expression, and one of the most famous equation of conversion of mass into the energy, you and I, everybody is well known to, is equal to mc square. So this is the limitation of physical world, physical knowledge, and whenever we are touching beyond this boundary, beyond the boundary of physics, metaphysics is coming, and here our philosophical and spiritual power comes into the play, and it gives us an understanding of the whole universe. And this is what the background of the gift of the books which I just wish to extend to our guest. One is related with spiritualism, that is one of the autobiography of Yogi that has explained about the science and spiritual and how the science is connected with spirituality, and how Einstein has also come up with theory of relativity as well as absoluteness of the only light in the universe. It is not going to change its characteristics anywhere, anytime. It is the only constant, it is the only unchangeable quantity which we can experience by the knowledge of physics or physical senses which we do have. And then he come to state about relativity. Every truth is relative. If we are sitting at this place, our frame of reference where we are fitting, according to that everything is all right. But whenever we are going to change the frame of reference to different place where space has changed, then all the quantity and characteristics of physical world is changing. When we are moving our frame of reference to other planets, again it is going to change. We are going to change our frame of reference to other universe, again everything is going to change. And beyond this, all the changes, absolute theory of relativity is coming out of that. Of course, the mathematical expression was left incompleted by Einstein, but still researchers are going through, and here we find a blending of physical knowledge as well as spiritual knowledge. So the gift of the book, which I am going to, with all due honor, going to extend to our guests and speakers, is containing all these things, as well as another book is Gita Acharan. That is a bridge between spiritual knowledge and the practical life. How to do it, understanding the spiritualism, based on the spiritualism, the truth, absolute truth, how we should do and behave and execute our all duties and responsibilities of being a human one. That two books I found very, very interesting. I always enjoy it, and I want to see that the joy should not be confined to me. It should be extended to our honorable guests, speakers. This is the background. That's all I wanted to say. And just you can continue.
Thank you, sir. I request Honorable Vice Chancellor, sir, to please present the books to honorable guests. Professor Maji, sir. To Dr. Geetam, sir. And to Professor Saad. Yes, sir, Saad. May I now request all the dignitaries to please come on stage for a photograph with the proceedings, please. इसके बाद बुलाऊं now I request all the participant delegates, faculty members to please come join for the group photo, please.
Especially the outside participants, please come.
All the participant delegates, faculty members, please join.
तो आप लोग बैठ जाएंगे पीछे भी लोग फैकल्टी खड़े हो जाएंगे
बैठ जाएंगे
हाँ आप लोग बैठ जाएंगे फैकल्टी मेंबर्स कैन स्टैंड
You see to understand.
आप इसमें बैठो नहीं आप बैठो या प्लीज मैम आइए ना प्लीज
Come fast. All of you come. We will respond. Sir. Please. For all of you, we are having in memory of the conference, please come out. Backside also.
सामने खड़े
Volunteers.
Student volunteers can stand in the front.
No, you can come here, please.
Yeah, please. हाँ, you can come in front. The student volunteers can sit at front.
I can please volunteers.
Ma'am, आओ.
Very good.
सर आप लोग भी आइए ना फोटो के लिए आप ही लोग कह रहे हो आप लोग भी आ जाइए छूट जाएंगे सामने हो जाता क्यों कर रहे हो सर लोग भी आएंगे आ जाओ नहीं वो